All right, this is lesson 6.3. This is the second part of it. I've got one more actually basic one, then we'll get into the couple tricky ones. So one more just hopefully to reinforce this idea. Here's the tangent of 5x, and it equals negative root 3. Don't solve that. Solve the tangent of x equals negative root 3. Where's the tangent negative? The second quadrant, the fourth quadrant. Let's stick with degrees again. That's a little bit easier. And what are your answers for that? Are you coming up with 120 degrees? And then down in the fourth quadrant, you come up with 300 degrees. Hopefully those are your two spots. And then you have to add on 360. But we have to do this 4 more times. We need 5 sets of answers. So add on 360, I get a 480. Or here, add on 360, I get a 660. All right, keep doing that. Add on another 360, I get an 840. Let's try not to make any mistakes, because once we do, it's going to mess up all the other ones. Add on a 360 here, is it 1020? You guys can check for mistakes. Add on a 360 here, how nice is that? 1200 on the button. Add on a 360 here, looks like 1380. And one more set, add on a 360, and it looks like 1560. And a 360 here is a 1740. All right, look at all those. You know, normally we get 2 answers. Tangent of 5x, we get 5 times as many. We get 10 answers. But because there's a 5 in there, make sure we divide all these answers by 5. So divide every one of these by 5. I'll just write that somewhat quickly. You can already set the division if you want. But hard to believe your good luck. You're not getting 2 answers anymore. This time you're getting 10 answers. So 120 divided by 5 gives us 24 degrees. 300 divided by 5, 60 degrees. 40 by 5, 96 degrees. 660 by 5, oh shoot, what is that? 132 degrees. 132 degrees. 840 by 5 is 168 degrees. Then we get 204 degrees, some very strange angles. And maybe you start looking and saying, oh, I see a pattern. These just keep going up by 36s. And you are right. They do. So that'd be another way to get the answers. I'll just continue with my division. 1200 by 5 is 240. Here we get a 276, which again is up by 36, I believe. Yeah. And then here we get a 312. And our final answer looks like a 348. 348 degrees. And those would be our 10 answers where the tangent of 5x equals negative square root of 3. Okay, that's the basic idea. How can we make this trickier? Not that you want to make it trickier, but how could you make it trickier? Something like this. And it's subtle, but the difference here is you've got a cosine of 2x and a cosine of x. And just like if you had a sine and a cosine, or a tangent and a cosine, or a tangent and a sine, something like that, these are really 2 different trig functions, and we cannot solve that when there's 2 different trig functions in here. So go back to chapter 5, and we had identities for the cosine of 2x. You had 3 of them, so you can look those up. But one identity for the cosine of 2x was 2 cosine squared minus 1. Another was 1 minus 2 sine squared. And the third one was cosine squared minus sine squared. Well, in this problem, since we have a cosine in here already, let's choose the one that has a cosine in here. Let's just do a substitution. Cosine of 2x is 2 cosine squared of x minus 1. We've got minus the cosine of x equals 0. Put it in descending order. 2 cosine squared of x minus the cosine of x minus 1 equals 0. And once you're to here, I'm going to leave it for this video, but once you're to here, this is a chapter 6, section 2 problem. You've done these before. Try to factor this, and once you've factored it, you can solve it. If you can't factor it, use your quadratic formula. But the purpose of this video is just to kind of put you back to the previous section. And to get there, we use that identity with a cosine of 2x in there. All right, let's look at the next one. Sine x, cosine x. Same thing, you have 2 different trig functions in here. Sine x, cosine x. Again, does that look vaguely like an identity that you had? Sine of 2x, which was 2 sine of x cosine of x. That's a known identity from section 5. So here's sine x cosine x. Let's divide both sides by 2 here, and I have sine 2x over 2 is sine x cosine x. Let's just use a substitution. I've got the sine of 2x all over 2 equals square root of 3 over 4. What will I do now? Well, let's get sine of 2x alone. I'll multiply by 2. So sine of 2x, when I multiply by 2, it cancels with the 4. And I get the square root of 3 over 2. All right, how do I solve that? Well, I don't. Instead of solving the sine of 2x, I solve the sine of x equals the square root of 3 over 2. Let's just stick with degrees. Where's the sine? Square root of 3 over 2, 60 degrees, 120 degrees. But there's a 2 in here, so I've got to add on my 360. I get a 420 degrees and a 480 degrees. And to all of those answers, divide by that number 2. So it looks like a 30 degrees and a 60 degrees and a 210 degrees and a 240 degrees. So not at all an easy problem. You started out with 2 different trig functions in there, but we use this identity to get it down to a single trig function. And we've solved it. Okay, final problem. 2 sine of theta equals 2 cosine of 2 theta. And again, you have 2 different trig functions in here, plus you got the 2 in here. So you go back to your cosine of 2 theta, those double angle identities, I'll write them again. We had 2 cosine squared of theta minus 1, 1 minus 2 sine squared of theta, and we had cosine squared minus sine squared. So which one would you choose this time? Well, choose one with a sine in it. So here I've got 2 sine of theta. Over here I've got 2, and I'll do a substitution. I'll sub in 1 minus 2 sine squared of theta. I will distribute 2 sine of theta equals 2 minus 4 sine squared of theta, and then I'll set this equal to 0. Actually, I can reduce everything by 2 also, can't I? First, I'll set it equal to 0. I'll add on 4 sine squared of theta. I've got my 2 sine of theta. I'll bring over that 2. So minus 2 equals 0, reduced by 2. And I've got 2 sine squared of theta plus sine of theta minus 1 equals 0. And once I've reached this point, try to factor it. Can you factor that? Yes, you can. So factor that and solve it, just like we did in Chapter 6, Section 2. Okay, so that's about as tricky as we can make these problems. This takes care of our video, and this actually takes care of the lesson, and it takes care of the whole entire chapter. So we will leave it at that.